Welcome back to All This Math. This is Professor Parker. Make sure you are subscribed to the channel. Make sure you like this video. Make sure you drop a comment below and make sure you share this video with somebody else, at least one other person. Two people is cool too, but at least one other person. All right. So look, what we got here. We got an LCM problem, an LCM problem. Now, first of all, what does LCM stand for? LCM stands for the least common multiple, the least common multiple. Now, first of all, what is a multiple? A multiple is a number that is the result of multiplying some other numbers together. For example, 18 is a multiple of 6 and 3 because 6 times 3 equals 18. Now, I want to make sure you don't confuse a multiple with a factor. A multiple and a factor are not the same thing. Like I just said, 6 times 3 equals 18. In that situation, in that scenario, the 6 and the 3 would be factors. The 18 is the multiple, aka the product. A product and a multiple are the same thing, right? They're the result of multiplication. Think multiple, multiplication, but it's the result. A factor is a number that can be multiplied by another number to result in a multiple. All right. So what we're looking for in terms of an LCM, like what is an LCM really? It's like a meeting point, right? Where two numbers, imagine these numbers were like people. Where's a good meetup spot for us? Like where we going to link up at? All right. Where's the 12 and the 40 going to link up at? All right. And what's the closest place we can link up at? Right. So if the 12 has to multiply itself by a certain whole number and 40 got to multiply itself by a certain whole number. Like what would that number, what would that meeting point be? What would that number be where they end up at? Where they end up at, right? Now, with this particular problem, one method that I would do, I would kind of just eyeball this. Like this one of them problems I would just eyeball. I would just eyeball the work, right? I would do 40 times, I take the bigger number, which is 40. I would do 40 times 1 and that equals 40. So 40 is a multiple of itself, right? Every number is a multiple of itself. That's something I ain't mentioned. But yeah, but 40 is a multiple of 40, but 40 is not a multiple of 12. So that means 40 is no good. Then I would do 40 times 2, and I would get 80. 80 is a multiple of 40, but 80 is not a multiple of 12. Because, and you should know your multiplication facts, because knowing your multiplication facts makes these problems a lot easier, right? Because I know that 12 times 6 is 72, and then 12 times 7 is 84, right? So those are whole numbers, right? Multiples come from whole numbers, right? So 80 is in between 72 and 84. So therefore 80 can't be a multiple of 12. Then I would do 40 times 3. That would give me 120, right? I know that 12 is also a factor of 120. So 120 is a multiple of 12 because 12 times 10 is 120. So if I was just using that method, then, just eyeballing it, that would be cool. I could do that, right? But there's other ways to do this. There's another method, right, that I like to call the Lumumba method. Online, some people call it the ladder method. But, one of my heroes, one of my revolutionary heroes is Patrice Lumumba from out of Congo, right? So I rather call it that. And you'll see why. So let's say I got 12 and 40, right? Now we already know the answer. The answer is 120, right? 120 is the least common multiple of 12 and 40. But we're going to do it another way because it's also important to know multiple ways, just like multiple. It's important to know multiple ways of doing math problems. All right, so let's do this. First, we're going to write 12, and then we're going to write 40. And then we're going to draw an L like that. All right, this is part of the reason I call this the Lumumba method, right? Besides the fact that I want people to know about Patrice Lumumba and then do their own research and Google or whatever about Patrice Lumumba and get books about Patrice Lumumba and study him and his movement and everything. All right. And other revolutionary African leaders of the past. But at any rate, so with this method, what we're going to do is we're going to look for factors. Now we're trying to find the multiple, but we're going to look for factors and use those as a tool so that we end up with the least common multiple. So we ask ourselves, what is a common factor of 12 and 40? All right. Now, it don't got to be the greatest common factor or the GCF, which you probably heard of before, right? It could just be any factor of 12 and 40. Now, I happen to know that 4 is a factor of 12 and 40. So, because I know 4 is a factor of 12 and 4 is a factor of 40. So because of that, I'm going to take that 4, I'm going to write it out here, right? Now, notice that this is like an upside down long division symbol. It's an upside down long division symbol. So keep that in mind, right? And we're still going to divide. So 4 is the common factor. We're going to do 12 divided by 4. That equals 3. So we write the 3 under the 12. Then we do 40 divided by 4. That equals 10. Write the 10 underneath of the 40. All right. Now, what we're going to do next is we're going to stop right here, right? Because these two numbers are what we call, it's a term for these, the relationship between the 3 and the 10. We call them relatively prime compared to each other. Now, 10 is not a prime number. 3 is a prime number. 10 is definitely not a prime number because 10 has 4 factors: 10, 1, 5, and 2, right? Now, factors are whole numbers that can, well, it could be integers, I guess, because it could be negative numbers. But factors are integers that can be multiplied in order to have a result or a product of that number or a multiple of that number. All right. But compared to each other, what common factor do they have? These are relatively prime because their common factor is 1. The only whole number or integer that both of these numbers have in common as a factor is 1. Once you get to that point, you stop, right? Now, this problem wasn't that long because there's only 2 numbers. So then we do this. We draw like a L. Use a red marker. Then we draw an L like this. And you don't got to draw the L, but I just like doing it. I like to get a little artistic. Do that. And now you got 4, 3, and 10. So what you do is you're going to multiply the 4 times the 3, and then the 3 times that product times 10. 4 times 3 is 12. 12 times 10 is 120. So like we said, 120 is the LCM. All right. So we did this. We just broke this problem down 2 different ways. All right. And this is the Lumumba method. As I said, online, it's called the ladder method. If you're in class, your teacher will probably describe it as the ladder method because Lumumba is just something that I call it. I ain't never heard nobody else call it like that. I hope it catches on though, right? Because I think we do need to evoke the ancestors more often. You know what I'm saying? But yeah. So this is how you find an LCM. And remember, what is an LCM conceptually, right? It's all good and nice to be able to know the process and the steps to find the LCM. But let's think about the concept. What is an LCM really? It's like a meeting point, right? Like where can 12 and 40 meet up at? That's the closest possible distance that makes sense for both of them, right? The closest possible distance for 12 and 40 to meet up at will be 120 because 12 times 10 is 120 and 40 times 3 is 120. Now the 40 doesn't have to go as far. 40 has to go 3 times as far from where it is or of itself, right? And 12 has to go 10 times as far, right? So the 12 becomes 120 and the 40 becomes 120 also. All right. So that's what an LCM is. All right. Stay locked in. I'll see you on the next video.